Hi, in this video, we will give the introduction about the noise control. Anything which can move the air can cause the noise. Typical noise sources include the vibrating structure, such as the panel or bell, air-moving devices, such as the fans, blowers, engines, compressors, or the explosion. For the engineering application, you might want to investigate the factory noise. That is due to the machine inside the factory. The noise inside the factory must be controlled to a safety level in order to ensure a safety working environment. Next, you might want to investigate the community noise, where you see an industry plant are located next to the residential area. In this case, we must ensure that the noise from the industrial plant can be significantly reduced to a safety level before it's transmitted to the residential area. By doing this, the noise pollution can be minimized or solved. Lastly, you have the transportation noise, where the noise is generated by the vehicles. So you can see in this case, the noise might transmit to the nearby residential area, and you might want to investigate what is the noise level and try to control the noise to the safety level. Noise can be transmitted through airborne, structure-borne, or the liquid-borne. For example, we have the airborne noise here. When this guy is knocking on the wall, the noise directly comes from the surface of the source. So this is called the airborne noise. You have a vibrating mechanical equipment here which generates noise. So if the noise directly comes from this equipment, then this is called the airborne noise or airborne sound. In simple, if a noise arises directly from the airflow, then we call it to be airborne noise. More examples for the airborne noise are given here. And you can see we use this symbol like this to indicate the airborne noise. Then beside the airborne noise, the wall will suffer the vibration, and the vibration will be transmitted through the structure. Lastly, it will generate sound far away from the original source here. The noise that is transmitted through the structure is called the structure-borne noise. This is the description for the structure-borne noise, where you see the sound usually arises as a vibration in some form, and this vibration can easily propagate over long distance as structure-borne noise. That is referred to the vibration transmission through the structure. Previously, you have learned that we can use this symbol to indicate the airborne noise, and now we can use this symbol for the structure-borne noise. So if you listen the noise directly from the machine, then this is called the airborne noise. If vibration occurs in the body of the structure, the vibration will transmit through the structure and cause some structure-borne noise. Structure-borne noise can propagate over a very long distance through the structure. So for example, in this case, you have a machine that is vibrating and is connecting to some structure. So this vibration will propagate over a long distance, let's say down to the second or third floor below it, and cause the structure-borne noise that is far away from the original source here. Lastly, we have liquid-borne or the fluid-borne noise. It is due to the pressure pulsation of the fluid. For example, in this case, so you have the liquid inside. If pressure pulsation of fluid occurs, then it will cause the fluid-borne noise, which is indicated by this symbol. Both structure-borne and liquid-borne noises can be propagated over long distance before the audible sound is formed. It's much more difficult to find the noise sources for these cases. One of the reasons that we wish to control the noise is about the sound quality. For example, consumers are willing to pay more for a quiet air conditioner, washing machines, and automobiles. So in this case, you can see that quiet is synonym to the quality. Besides that, noise can affect the worker productivity as well as the job satisfaction in the workplace. Hearing loss of the worker due to high noise exposure in the workplace might cause high defending and settling damage claims. Therefore, it is important to control the noise in the workplace. Moreover, we need to control the noise to a safety level that is compliant with the legal standard. For example, OSA legal standard concern about the high noise working environment, such as 80 dBA and above. So in this case, they might impose the noise limit not to exceed 85 dBA in order to protect the workers from the excessive noise level. The noise limit for the residential area is more stringent. For example, you can see a typical nighttime limit in a residential area is around 45 dBA. In order to ensure the sound quality of the product, ensure the productivity and job satisfaction of the worker in the workplace, as well as to avoid the damage claim from the worker due to the hearing loss. Lastly, we want to comply the noise limit with the legal standard. So these are the reasons that we wish to control the noise. By definition, noise control is the process of obtaining an acceptable noise environment for a particular observation point or receiver, involving control of these three items. First of all, you have the noise source. Secondly, the noise will transmit through the path, which is the transmission path. Lastly, the noise will reach to the receiver. In order to control the noise to an acceptable level, we can implement the noise control strategy in these three areas, and we will discuss this later. In general, noise control engineers need to understand the following knowledge, such as the acoustic, mechanical vibration, as well as the fluid mechanics. To become an effective noise control engineer, not only the physical principle, the engineer need to master the engineering tools for the analysis and measurement, as well as the common sensation. For the noise,